All right, let's jump right in. Today, we're tackling a massive question for pretty much any big company out there. How do we get AI agents to actually be useful for complex, real-world jobs? And here's a spoiler. The answer isn't just a bigger AI model. It's about completely rethinking how we handle knowledge itself.
So, this quote really hits the nail on the head. You see, AI agents have all this incredible promise, right? But inside a real business, they just seem to hit a wall. And the reason, as this research points out, isn't that the AI isn't smart enough. Nope. The real problem is that an agent can't possibly know all the unwritten rules and the specific way we do things around here that makes your organization tick.
And this leads to this enormous hidden cost, which the source material calls the institutional knowledge tax. You know what I'm talking about. It's that constant drain on your most experienced people, your seniors, your architects, the ones who are always getting pulled away from their actual work to explain how things really get done over and over to both new hires and AI agents. This tax feeds directly into this super frustrating and wasteful loop. The agent tries to do something, it fails because it's missing that key piece of context. A senior engineer has to stop what they're doing to correct it, and then the agent tries again. This context rot cycle doesn't just slow you down, it can actually kill productivity.
So, the big question is, how do we break this cycle? Well, the solution here is a pretty fundamental shift in how we think. We need to stop just giving agents a bunch of documents to read and hope for the best. Instead, we need to start activating our knowledge so it's ready for direct execution.
And this table right here perfectly shows the difference. On the left, you've got your standard approach, RAG, which is basically like handing the AI a chapter from a textbook. The AI still has to read it, interpret it, and then figure out a plan. But with knowledge activation on the right, it's totally different. We're giving it a precise, action-ready recipe, a skill that tells the agent exactly what to do, how to do it, and what rules to follow. And we get there through this three-stage pipeline. First, you codify all those unwritten rules and processes from your experts. Then, you compress that knowledge into a super dense, efficient format. And finally, you inject that specific knowledge into the agent's brain at the exact moment it needs it. So what comes out the other end of this pipeline? It's a really powerful new building block for enterprise AI. It's called the Atomic Knowledge Unit, or for short, an AKU. The best way to think about an AKU is as a hyper-specific, self-contained AI skill in a box. It's not just a document, it's an executable package. It has everything an agent needs, the step-by-step procedure, the right tools, the rules, the permissions, all to perform one single task correctly and safely inside your company. So, what's in the box? Well, this is the secret sauce. Every single AQ is built from this 7-part schema. It covers everything from what the skill is for, to the exact step-by-step how-to, all the way to scripts that validate if the job was then right. This structure is what makes all that messy human knowledge predictable, machine-readable, and, well, composable. You're turning processes into building blocks for AI. Okay, I know that can feel a little abstract, so let's make it super concrete. We're going to walk through 2 detailed, real-world examples from a software team to see exactly how this 7-part schema helps an AI agent actually get work done.
We're going to look at a proactive task, something you plan to do, like deploying new code. And then we'll look at a reactive task, something you're forced to deal with, like when a system goes down and the alarms start blaring. Okay, first up, deploying code. The skill starts with a really clear intent declaration. It tells the agent exactly when to use this. Then you get the procedural knowledge. And look, this isn't a vague suggestion. It's a precise step-by-step checklist. It codifies best practices, like starting with a safe 5% canary deployment and then watching it for a while before rolling it out to everyone. This is how you make sure things are done the right way, every single time.
And this is where the magic really happens. The governance constraints are baked right in. Who can do this? When can they do it? Does a human need to sign off? But what I think is truly brilliant is the inclusion of anti-patterns, the big do not list. You are explicitly telling the agent about common, costly mistakes like deploying straight to 100% and preventing them before they can ever happen. Of course, the skill isn't working in a vacuum. Tool bindings point to the exact internal APIs the agent needs to use. No more guessing which system to call. And the organizational metadata provides that crucial context, like knowing this is for the production environment and being able to dynamically look up which team owns this service if something goes sideways. And finally, the skill knows what to do next. Validators are little scripts that double-check things before and after, making sure nothing breaks. But the continuation paths are absolutely key. They tell the agent which skill to use next. If the deployment works, great, move on to verification. But more importantly, if it fails, it knows to automatically trigger the rollback deployment skill. This is how you build automation that's actually resilient. All right, now for our reactive example, something's on fire. The intent is crystal clear. A critical alert just fired. Now, in a high-pressure situation like that, the procedure brings immediate order to the chaos. It knows to acknowledge the alert, find the right person, open a standard communication channel, and start gathering data automatically. There's even a built-in timer to make sure it gets escalated to a human if the agent gets stuck. And just like before, the rules and tools are embedded. Governance constraints make sure only authorized people can respond, and it even mandates a review afterwards. The tool bindings are super precise, pointing to the exact APIs for acknowledging an alert or creating a Slack channel. This removes any chance of human error when time is critical. Now check this out. Pay close attention to the continuation path here, because this is what makes this whole system so unbelievably powerful. If the agent's diagnostic suggests the incident was caused by a recent deployment, it automatically triggers the rollback deployment skill we saw in our first example. This is the key. Skills can call other skills. You can compose complex, reliable workflows from these simple, trusted parts, just like Lego blocks. What these examples really show us is something pretty profound. When you start packaging your institutional knowledge into these AKUs, you're not just creating a smarter wiki, you are building an executable, interconnected graph of your company's operational wisdom. So what that really means is that agents no longer need to guess or try to read every document in your company. Instead, they get just enough context, just in time, to perform one specific action safely and correctly. That's how you make complexity manageable. And this opens up a future of what the research calls AI-generated golden paths. Instead of just following some rigid, predefined script, an agent can intelligently chain these atomic skills together on the fly to handle brand new, complex requests it's never seen before. You know, this also fundamentally changes the job of your internal platform and tooling teams. They go from building brittle, hard-coded automation that's always breaking to becoming curators of this rich, living library of reusable skills that empowers both AI agents and humans. And that leaves us with one final, and I think pretty provocative question. Is your company's most valuable asset, all its collective knowledge, just sitting on a digital shelf for people to maybe read? Or are you turning it into an active, executable engine? Because architecting your knowledge this way, well, it's more than just a technical upgrade. It's a core competitive advantage in this new age of AI.